All right, so we're live, everybody, right? So let me share this live stream. So let me share this live stream and then we'll begin. All right, so some persons are already there. All right, so the persons joining in, share the live to your friends so that everybody will know you are. Our, our persons are very early. Yeah, so share the live with your colleagues and so on. Let them know that we are live. Let me begin sharing it. All right, so I trust that everybody's doing well. Everybody's good. Let me just share this live on my Facebook page. Then we will begin. All right. So while you're watching, just comment and tell me which school you're from, so we'll know how we were represented. So as you can see, I'm not alone tonight on the live. I have some students here with me. Some students they want to come and we'll all revise together. So you will be hearing from myself and from some very brilliant students as we prepare for this very lovely exam. All right. Okay, I see a lot of persons. We are 190. Yeah, good. I see Annandale, Golden Grove, Harmony Secondary, Charlestown, Cottonfield, Kokwani, Queens College, Queens Covent Garden, Buxton, Port Kaituma. All right, Kanji. Good. So in a few we'll begin. Let me just send this message to one more group. Right. Attention, North Georgetown. All right, good. Arms. Okay. We were stretched all the way across the country. Good. So while we await in a few minutes, we'll begin the revision session. So I have some students here, some very brilliant students, as I said earlier. And before we begin, I'll ask them a few questions and then we'll head straight into the revision. So we have Ambor, Akeem, Deviani, Troy, Shaniqua, Talia, Kevin, and Alia. So how many of you? Anyways, the few of you here, what is the count until the exam? Somebody remind me and tell me quickly. How many more days do we have? How many more?
41.
41 more days?
Yes, sir.
41. This is a long time or a short time?
Very short time.
Very short time. Good. So right now we should be dotting the I's and crossing the T's and polishing up so that we can do well in this exam. So quick question, how are you feeling about the exam? As from the student's perspective, how do you feel about this big maths exam, this challenging exam that people would say? Are you excited, nervous, or both? Or how would you describe your feeling? Start off with anybody can go.
Right now, I'm nervous, but I feel like when it's time to write the exam, I'm gonna be ready.
All right, you're going to be ready. Good. And also the persons in the chat, you can also tell me how you're feeling. Are you nervous or excited? The person's looking on. So next person, Amber, how are you feeling?
Sir, I'm good, but there's still a lot of subjects I need to tighten on.
Okay, all right. We are far. The one day is to tighten up on them, right? Akeem, what about you?
They're doing good so far.
Okay, excited about the exam?
Not really.
Not really. Deviani, what about you?
I'm having a combination of both excited and nervousness, but I just really want to get CSEC over with.
Just want to get C-Sec over with. Troy,
So I think I'm almost prepared enough for the exam.
almost prepared enough. Shaniqua, what about you?
Sir, I feel like I'm halfway there, but I just want to do it and get it over with.
Okay. And Talia and then Kevin.
Sir, I feel the paper gonna be easy, and I just want I just want to finish it.
Okay. And then
Sir,
Kevin.
I think I'm good overall, good for the exam, but just a little bit more practice, and I should be at the point I should be for the exam.
Okay. And Alia, you went already, right?
Yes, sir.
Good. I good. So I see in the chat persons are saying that they're nervous as well. And let me tell you how I'm feeling from the teacher's perspective. I'm excited. I'm excited for y'all because I know as long as you prepare, you will do well. And I'm excited to see the results that your preparation will bring. All right, so let's not waste any more time now. Let's head straight into the revision. So some persons here, they're nervous, emotions are all over, anxious and stressed, nervous, excited, lovely, nervous currently, but I'll have confidence coming close to the exam. Okay, all right, all right. There's a thing that used to happen to me. It's something called exam adrenaline. I I would normally when I attended school, I would normally get that in exams. You know, people get nervous in exam, but in exams there's this little extra thing that would happen, you know, that would give you the push in the exam. Things that you would do in the exam you can't do on a normal day. Nevertheless, let's head straight into our revision. All right. So let's head straight into the revision part. Um, so we'll try to cover as many things as we can, and we'll at leaving this session tonight, you should be in a completely better place than you were before you joined. And that is the whole objective of this session. So if you're joining in, just ensure you share the link to your colleague, share the link in your class group, share the link on Facebook, wherever app you use as young people, TikTok. Yeah. So that everybody can join and they can and learn something, all right? So let's go. So the first thing I want to tell everybody here, something that you all should know by now is the format of the exam and how the exam will come. So the exam has three components, paper one, paper two, and paper three, or the SBA. And as you all should know, paper one is worth 30%, the SBA is worth 20%, and paper two is worth 50%. So given the fact that the paper two is the exam closest right now, we will be working some paper two concepts and some paper two questions and ironing out some things with paper two. All right. So the paper two is worth 100 marks, and that will scale down to 50%. So basically, whatever marks you get, you'll divide it by two, and that will be your percentage out of 50. So those are the things. And then in the next live, we will focus on preparing for paper one. All right. Good. So let's head straight into paper. Let's head straight into the paper two concepts. So I want us to start off looking at some algebra, right? So the reason why I'm starting with algebra, is because algebra is the foundation of mathematics. You must have a good foundation in algebra if you want to pass and also do well in mathematics. If you don't have a strong foundation in algebra, you're not, you may struggle. So so let's start off with some algebra. So I will start off with some basic things and then I'll head into some questions. So the first and most important thing I want us to talk about would be this very important thing, which is like terms. And I want one of my students to briefly tell me what are like terms quickly. What do you mean by like terms? Very short and sweet answer. I'm looking for.
The like terms must have the same variable and
Mhm.
raised to the same power.
Very good. So like terms basically have the same variables and they are raised to the same power, as Troy rightfully said, right? So basically, if I have, for example, so they must have same variable and same power. So the thing is, the important word here is and. They must have both of them must be the same for it to be a like term. They can't have or. So for example, if I have 5y, some like terms with 5y would be half y, um, negative 2y. What about if I had 5y squared? Would this be like? Somebody tell me quickly. In the chat as well. Would those be like as you're watching? I'm not into papers yet. I'm just briefly going over the concept and then I'll go into the paper. So I'm looking at the chat and also persons in here, right? So would this be a like term? 5y squared.
No, sir.
No, definitely not, right? So the thing is, we tend to take these things for granted, this basic concept for granted, and this is what causes us to lose a lot of marks in the exam. So we must understand like terms. As long as they have the same variable, the same power, they are considered like. So the next thing we want to look at would be unlike terms. And what are unlike terms? Anybody? Looking at the chat and also forces here. What is it?
Unlike terms have different variables or different powers.
So different variable or different power. See, the important thing here is either or, right? Either they have a different variable or they have a different power. All right, either one could be different and they're unlike. Now, the reason why we should be able to identify like terms and unlike terms because when we have to work with algebraic expressions, work with algebraic equations, we must be able to identify like terms because we can add like terms or we can subtract like terms. All right, it's very important to be able to identify them. So for example, let me just do a quick one. So we can add like terms. So for example, if we have 5x plus 3x plus x plus 2y, what would this be? Looking at the chat as well, right? Yeah. So this will simply be 5x plus 3x plus x. This is like you have 5 plus 3. And when you have a variable here by itself, we know this has a coefficient of 1, right? So 5 plus 3 plus 1 would give me 6x plus 2y. We can't take this any further, so this would be the answer. The reason why we cannot take this any further because these two terms, they are unlike. We cannot add unlike terms or nor subtract, right? Very important concept. This is the foundation of algebra. Now, with that being said, let's head into some questions. Let's head into some past paper questions. I just wanted to touch on these. All right,
Sir,
go ahead.
sir, 5 plus 3 plus 1 is 9.
Okay, just checking to see if you are paying attention. Good. Good. And also persons in the chat are paying attention. I see some people have 9x squared. y. Now this okay. I'm glad that everybody's paying attention. Good. So 5 plus 3 is 8. 8 plus 1 is 9, right? So 9x plus 2y. Good. So with that being said, now that the foundation is set, let's head into some past paper questions. Let's head in and work some questions, right? So don't ask me for the year. I don't know the year. These are just some questions put together. As they come up, you can work them. So I have some questions here. Somebody said it thought they were tripping. So I have some questions here. So factorize, and then we are asked to change the subject of the formula, then we are asked to find the value of something, and then we are asked to write an expression, and then we are asked to calculate. So let me zoom up. So when you see a question asks you to factorize, now students tend to mix up factorize, they tend to mix up factorize with solving and with simplifying. So it's very important to be able to differentiate between factorizing, simplifying, and solving, right? You have to be able to differentiate between those key terms in mathematics. When you see the term factorize, your mind should immediately jump to factor. You want to express whatever as factors. When you see solve, you're finding the value of something. When you see simplify, you're making it simple, right? So the answer to the question, the answer to the instruction, it's in the name, right? It's in the word itself. Factorize, your mind should be thinking about factors. So we have to factorize completely. We have two terms. Let me zoom out back. So we want to factorize, let me write it up here. So it's 2x to the third power minus 8x. So we're asked to factorize this here completely. So when we have two terms like this, you're asked to factorize. So if you already have the answer, you can send in the chat, right? Before I work it. So when you ask to factorize two terms, we do use the distributive law method. Because these two terms are not perfect square terms, we use a method called the distributive law. So basically doing the distributive law in reverse. So what we do, we look at the two terms and we see what is the highest common factor between these two terms. I would always tell students to start off with the numbers for us. So we have 2 and 8. What is the highest common factor between 2 and 8? We factor out, yeah, let me hear.
2x.
2x. All right, yeah, we factor out the 2x. And we factor out the 2x from this first term, we see we're left with, when you're factorizing, you're basically dividing. So this is 2x to the third divided by 2x. This 2 will go with that 2. This x will cancel to this here. So we're left with x squared. Subtract. We factor out 2x from x squared. This x will go with that x. 8 divided by 2 would be 4. So you're left with minus 4. And this would be the answer for that question, as many persons rightfully said in the chat. All right. So the next one says we have to factorize this one. So this is 3x squared minus 5x minus 2. So we asked to factorize this. So the students that I have here, how can we factorize this? What method do we use?
Sir, we can
AC
use
method.
the AC method.
We can use the AC method, and we all love the AC method, right? The AC method should be our best friend. When we deal with factorizing, we should smile when we see we have to use the AC method. So I'm somebody here. How can we why do we use the AC method? Why? How do we know we have to use the AC method? Go ahead. You can
Sir,
just jump in, right? Go ahead.
it's a quadratic.
How do you know it's a quadratic?
Well, sir, the first term has a square,
Mm-hmm.
and then the other one just has a variable, and then the other one's just a number.
Yeah. So it's in the general form for a quadratic, right? And the general form for a quadratic is ax squared plus or minus bx plus or minus c, right? So as long as an expression is in this form, it's a quadratic expression, right? So the first thing to do when you deal with the AC method is to identify what is A, B, and C. So when we look at these terms here, my students that I have here and also the students in chat, what is A and what is B and what is C? What is A?
There are
A
three,
is 3. And what is B?
Negative.
5, negative,
B is
negative 5,
-5 and C is
negative 2.
-2. So it's very important. We can't just say B is, some people jump and say B is 5, and then that will lead to a lot of errors. We have to look at the term in front, not the term, the sign in front. The sign in front will govern the sign, govern the term. So B is a -5 and C is a -2. All right, so don't be carried away and just say 2 and 5. Very important thing. That is where a lot of students will lose marks in questions like these, and they wonder how they find any number, or why is it that the brackets are not the same, because the signs play a very important role. So let's go. We have A, B, and C. The next step to do with AC, we multiply A by C. So we know A is 3 multiplied by C, which is -2. So 3 times -2 would be a -6. And now I'll open the question. After we finish finding AC, what is the next important thing we want to find? What is the most important thing we want to find? After we find AC, what else do we do? Students here. Go ahead.
So you find two numbers that when you add them, you get -5.
Mhm.
And when you multiply them, you get -6.
Good, very good. So we want two numbers. When we add, we should get B, which is -5. And when we multiply, we should get AC, which is -6. And what two numbers y'all have in mind?
1 and 6.
1 and 6. Anything? Just 1 and 6? Anything else with them?
Actually,
Um,
sir, negative.
One and
Negative 6 and 1.
-6 and 1. Amr, say something?
No, sir.
So -6 times 1 would be -6 indeed. And -6 plus 1 would give me a -5, right? So this checks out. So we use this here, we substitute and replace the bx term, which is -5x. So we'll now have 3x squared minus 6x plus. Now we are putting these two terms inside, right? But we are putting whatever variable we have here, we are putting that in front. So that's what we have. Instead of -6, we have -6x. And this will be plus 1x, but we know in algebra, you don't put back the 1, so it will just be plus x minus 2. All right, and now we have 4 terms, so we just pair them off. Some people would say a pair without, not like that, but however you're comfortable. And then we factorize the two brackets. So we have 3x squared minus 6x. And we do just like what we did earlier here. Where is it? We do just like what we did here with the two brackets. So we have 3x squared minus 6x. And what is the highest common factor?
3.
The highest common factor is
3x.
3x, good. So we factor out 3x from this first term, we're left with x. We factor out 3x from -6x, we're left with -2. And then we look at the first term, so we factor out the plus. Between x and -2, what is the highest common factor?
1.
1, right? Nice and easy. So we don't have any factor common other than 1, we just factor out 1. And we're left with x minus 2. So now that we are at this step, and we're dealing with the AC method, what is one indication that we are going the correct way? There's one thing in this step that can indicate that we are going correct.
So you have expression in both brackets.
We have
The same expression in both brackets.
We have the same expression in both brackets, right? So yeah. So the last step now, we just take what is outside the bracket and we put that in a bracket. So this will be 3x plus 1 in a bracket, and then we have x minus 2 in a bracket. And Bobs, all of the marks belong to us, and we are one step or we are 2 marks closer to passing the math exam. All right, good. So that is that. All right. So the next thing now we have to change and we have to make C the subject of the formula. And we have F is equal to 9 over 5 C plus 32. And we are asked to make C the subject of the formula. So let me see if I can get some space. Should have worked it sequentially hard. Yeah. So you make it C the subject of the formula. And when it says making this change, making C the subject, what does that mean? Anybody, when it says make C the subject, what does that mean? What are we doing with C? We erasing C, deleting C? What are we doing?
We're making the equation equate to
We,
C.
we are
Making the equation equate to C.
making the equation equate to C. All right, good, yeah. So basically, we want C to be on one side of the equation by itself. Nothing else attached to C. C has to be alone. C doesn't want to be surrounded by anybody. C is going through a tough time and wants to be by himself, right? So we're making C the subject of the formula. So to make C the subject of the formula, we'll take over everything and leave C. So the force we want to take over is the plus 32. So we'll take this over the equal sign, and when it goes over, what will it become? To be F. This is adding here. Sorry, go ahead. Go ahead, Viviani.
Then be negative 32 when it carries over.
So it's adding, and we take the over subtract, so it'll be F minus 32 is equal to 9 over 5C. And this 9 over 5C, this is like 9 over 5 multiplied by C, right? This is the same thing as 9C divided by 5. Same thing. So next thing we want to take over is the 5. The 5 is dividing, and the opposite of division is multiplication. So we take it over to multiply. So this will be 5. Now this 5 has to multiply everything. So we have to put it like this. This 5 multiplied by F minus 32 is equal to 9C. So we cannot write it like this. You cannot say 5F minus 32. This 5 will just be multiplying this F. The 5 has to multiply every single thing. If you put like this is wrong. So in order to show that the 5 is multiplying everything, we put everything in a bracket and we multiply it by 5. Very important. And the next thing that we want to take over is the 9. So the 9 is multiplying, and we take it over to divide. So we'll have, remember the 9 has to divide every single thing. So it will be 5, open bracket, F minus 32, all divided by 9 is equal to C. And if you want, you can rewrite this and say C is equal to 5 multiplied by F minus 32, all divided by 9. And hence C is the subject of the formula. All right, so C is by itself. C is now the subject of the formula. Very as easy as that. So how many marks that went for? 2 marks. So once again, if you got it correct, you're 2 marks closer. If this a question like this came, you're 2 marks closer to passing the exam. So we're taking it 1 mark at a time in the exam. And that is one important thing you want to do. Take it 1 mark at a time. Don't try to look through the entire paper and get nervous. Just take it 1 mark, 1 question at a time. All right, so the next one says, so we're looking at the chat, everybody. Are we looking? We're looking good so far. The person's looking on YouTube. Are you saying they're hungry? Yeah, I'm hungry doing maths. Why? Somebody, Troy, put you on the spot. Let me not put you on the spot. All right, so let's go. Grade ones for everybody in the chat. I'd love to see it. Talia, is that you in the chat as well?
Yes, sir.
Okay. Yes, grade one for everybody in the chat. Somebody say we good. Yeah, so let's go. So next one says 500 tickets were sold for a concert. Of these, X tickets were sold at $6 each, and the remainder at $10 each. So they say write an expression in terms of X for one, the number of tickets sold at $10 each. So this is a nice one that I have to type in the chat. Did I miss a question? No, oh, yes, I did. So it says given that F is equal to 113, calculate the value for C. Yes, I didn't miss that question. So if F is equal to this, they want us to calculate the value for C. So I'll work it right here. So F is equal to 113. So they want us to calculate the value of C. So I work it right here. So C is equal to 5 multiplied by, now instead of this F, I'll have 113 minus 32 all divided by 9. So they said 113, right? Just checking. Okay. So all you need to do is just punch it in the calculator and get the answer. So you can just do 113 minus 32, and then you multiply that answer by 5, and then you divide that by 9, and you get C is equal to 45. All you need to do is know to use the calculator. Yeah, all you need to do is know to use the calculator, and one easy mark give away. CX was very kind here. So that was that nice and easy one mark. So back to this question. So 500 tickets were sold for a concert. Of these, X tickets were sold at $6 each, and the remainder at $10 each. Write an expression in terms of X for the number of tickets sold at $10 each. And this is going for 1 mark. So when you see 1 mark, it's a nice and easy mark. So students on the live and also students in the chat, what is the answer? The number of, I want an expression in terms of X. Now when I say an expression in terms of X, that means the only variable you should be seeing in this expression is X. You can have numbers as well, but the only variable you should be seeing is X, no other variable. You can have numbers attached with the X, surrounding the X, but just X alone. No other variable. So when I say in terms of whatever, just those variables you should be seeing. So anybody here, number of tickets sold at $10 each.
Sir, 10 open bracket, 500 minus X. Close bracket.
500 minus X. All right. So we know we had 500 tickets in total. And of these X tickets, so we don't know what is X, but X of those tickets were sold at $6. So, and the remainder was sold at $10 each. So out of the 500, X amount was sold at $6. So it will be 500, subtract X, multiplied by 10. Excellent. So those of you got it correct. I see Nikisha Rose got it right. Very good. 1 mark closer. So the next one, they want an expression in terms of X for the total amount of money collected for the sale of 500 tickets. So look how I can lose marks. Just be careful. Yeah, anybody up here? Total amount of money collected for the sale of the 500 tickets.
Six X plus 10 open bracket, 500.
Yeah, go ahead. Sorry. 6X
Plus 10 open bracket, 500 minus X.
All right. So yeah, we know this is the amount of tickets sold at $10 each, and we know 6x is the amount of tickets sold at $6 each. So the thing is, we can actually simplify this a bit further. Can we simplify this a bit further?
Yes, sir.
All right, so let me just, so the thing is, this is the amount of tickets sold at, see somebody saying they don't understand. So this is the amount of tickets sold at $10 each. And then the rest of tickets were sold at $6 each, so it's just 6 times the x. All right? So this is what we found for us, and then we just added on that with 6x, and that will give us the total amount of tickets sold. So what we can do, we can simplify this further. So let me just carry this over. So we can simplify, we can multiply. So we'll have 6x, and we have 10 multiplied by 500, that will give me plus 5,000. And 10 multiplied by negative x, that will give me negative 10x. And we just put the like terms together. So this will be 5,000 plus 6x minus 10x. And this will be 5,000. 6x minus 10x, that will just give me a minus 4x. And this will be the expression. All right. All right, so somebody say the last one there. All right, let me do it quick. Let me do it over. For those who in the chat that's saying we lost you. So here's the thing. The question says 500 tickets were sold at a concert. So in total, we got 500 tickets. All right. So in total, we have 500 tickets. And of these 500 tickets, X tickets were sold at $6 each. So this X represents an amount from this 500. So to get the amount of tickets sold at, well, to get the amount of money that you made from selling X tickets, remember one of the ticket cost $6. So in total, if you want to find the total amount of money made from selling X tickets, it would just be the cost for one, which is $6, multiplied by the amount of tickets sold, which were X amount. So the 6 times X would be 6X. So this represents a portion of the ticket. And then the next one said the remainder of tickets were sold at $10 each. So if X amount of tickets were sold at $6, remember this X represents a total that we don't know. So out of the 500 tickets, X of them were sold at this amount. So it will be 500 minus the X, because this X represents an amount that we don't know. So it's 500 minus the X tickets sold, and then to get the amount of money that they made from this here now, we multiply this by the cost of one ticket. So the cost of one of this ticket was $10. So what we do now, to get the amount of money made from this, we just multiply this by 10. And this will give us the amount of money made when we sold a ticket at $10 each. So this represents a portion and this represents a portion. So what we do now, we just add them together. We add the 6x plus this here. So it'll be 6x plus the 10x, well, the 10 multiplied by the 500 minus x. And then we just multiply 10 times 500 would give me 5,000. 10 times negative x would give me negative 10x. Then I put the like terms together. So whenever we put in like terms together, we just move with the sign in front. So we put this 6x here with the minus 10x. So 6x minus 10x, that will give me a negative 4x. So that's how I end up with 5,000 minus 4x. So the last part of the question says, the sum of 4,108 was collected for the sale of 500 tickets. Calculate the number of tickets sold at $6 each. Who would like to help me out with this one? Anybody? This is the sum of 4,108 was collected for the sale of 500 tickets. Calculate the number of tickets sold at $6 each. This one is a little tight one because it's going for 3 marks. So what do we do here? Anybody's help me or do I have to work it? Viviani?
So you write the equation from B and you just put it equal to 4,108 and you work out. Basically making X the subject.
Okay. All right, so which equation we had from B? What is the equation from B?
6x plus 10, open bracket, 500 minus X.
Oh, we simplified that. What we got?
Negative 4x plus, negative 4x plus 5,000.
So we can say 5,000 minus 4x. I say equate that to 4,108.
Yes, sir.
All right, so let's go down that path. So it will now be, so we solving for x, and that would give us one ticket. So this will now be negative 4x. So we take over this 500. So this is a plus 500. We take it over, it will subtract. So this is equal to 4,108 subtract 5,000. This will be negative 4x is equal to, and we subtract this, we should get negative 892. And then to solve for x, it will be negative 4. So we want to solve for x, so we take over the negative 4. It's multiplying, and take it over, it will divide. So we'll have x is equal to negative 892 divided by negative 4. So x would be 223. Is that the answer?
Yes, sir.
Yeah, so we can say therefore, so remember they told us that X tickets were sold at $6 each, and since we found the value for X, this is telling you how many tickets were sold at $6 each. So we can say therefore 223 tickets were sold at X dollars each. So we just had to use the answer that we got from B and then just equate it to 4,108, and then we solve for X. All right, so let's carry on now. So we want to factorize. So remember earlier I said factorize. When you're factorizing, the important thing you need to look at is the word factor. So whenever you're factorizing, that should be the first thing that pops in mind, factor. So we have the first term here we want to factorize, which is xy minus y squared. So what we want to do, we know these are just two terms and they're not perfect square terms. They're not perfect. They're not squared terms. So all we need to do is use the distributive law method to factorize this. So we look at xy and minus y squared, and we see the highest common factor here is simply y. So we factor out y, and when we factor out y from here, we're left with x. And when we factor out the y from y squared, we're left with simply minus y. And that will be the answer. And then this one here now, we're asked to factorize this. So we see we have x squared and we have y squared. And the thing about these two terms, this here, we can multiply something by itself to give you x squared, and we can multiply a term by itself to give you y squared. So once we have once it's like this, it's a nice and easy way to factorize. We call this difference of two squared, simply because we have a subtraction sign and we have two squared terms here. So you can factorize this as difference of two squared. So what we do, we basically open two brackets, and then we ask ourselves, what can we multiply by itself to give you x squared? So we know x multiplied by x will give us x squared. So what we do, we just put an x here and an x here. And the same thing for the y squared. We know if we multiply y multiplied by y, that will give us y squared. So we take the y here and we put a y there and put a y there. And in one bracket we add, and in another bracket we subtract. And this is how we factorize when it's like this, difference of two squared. All right, just to make this a bit clearer, if we had something like x squared minus 100 and we are asked to factorize this, from the time you see I have two terms and they're subtracting, and the two n terms, and the two terms are square terms. And by square term, I mean if you can multiply something by itself to give you the term, you factorize it as a difference of two squared. So you open two brackets, and you ask yourself, what can we multiply by itself to give you x squared? We know x times x will give you x squared. And then we ask ourselves the same thing for the 100. What can we multiply by itself to give you 100? We know 10 times 10 would give us 100. And in one bracket we add, and in another bracket we subtract. And this is how you factorize expressions like these. And these things go for typically 1 mark because they're very easy. But you just need to be able to identify them. All right, so let me just erase this additional example that I give. So the next one, so the thing says now, hence simplify. So when you see the word hence. Hence means you basically have to use what you got at the top here to simplify this here. So anything says simplify. Now, earlier I was emphasizing on some terms, simplify, factorize, and solve. When it says simplify, you make it a bit easier, a bit shorter, simpler. That's what it means to simplify. Simplify does not mean solve or find any value. Simplify means make it simpler. All right. So we're asked to simplify this. And if you look at these two terms, it's basically what we have here and what we have here. So we have to use the answers that I got at the top here to simplify this. So this will be, so we saw here, we factorize that to become, let me write it here. This will be the answer for here. So we factorize the top here to become y open bracket x minus y over, and then we factorize at the bottom here to become this thing here. So this will now be divided by x plus y in a bracket multiplied by x minus y. So here's the thing. Everything at the top is multiplying by each other. Well, this bracket is multiplying by this bracket here. And then this bracket is multiplying by this bracket. So because this is happening, we can do some canceling out. So we can cancel out the brackets that are the same. So we see this bracket is the same as this bracket, so those two can cancel out. So this bracket will cancel to that bracket. And hence we're left with y over x plus y. And that is the answer here. And that is how we simplify this. Right? By the time you see hence, that should give you an indication that you got to use what you got at the top to find, well, in your answer. And of course, if you got these here wrong, then chances are you will get this here wrong. right? So CXC will give you some simple things to do at the top, and then you will, have to use those simple things to find an answer at the bottom. Sometimes. So of course, if you get the simple things wrong, you won't get the big marks. All right, let's carry on. Our students on the Zoom, on the live, are tired? Amber, Viviani, Troy, Alia, Kevin is so tired, is so silent. And the people on the chat, are tired or we looking? We cooked, or we cooking. This is a
Cooking.
term, this is a term I use as teenagers, right?
So I feel like me gas halfway finished. Correct.
Gas halfway finish.
Mm-hmm.
Okay, gotta go massy and buy new gas.
Sir, I'm on an
Yeah.
electric stove right now.
What is that?
I'm on an electric stove right now.
Electric stove. So that means you're cooking with electricity. Okay. Let me see. Somebody say they're cooking, we cook. Why you say we? We cooking, we are cooked. Coffee break, wide awake, too late to cook, we cooking. I did I went to bed yesterday. So, okay. Or yeah, still use the term cook. Or is that just something in the past? Is that something I still use as teenagers, young people? Okay, I'll take that as a yes. All right, so let's go. Now let's move on to a solving. So we're asked to solve for x, where x is a real number. And we have an expression, well, an inequality here, where you have to solve for x. So whenever you're solving for x, you're finding the value for x. All right. So this is an inequality, and we solve this just like how we solve a normal equation. Right? We solve this just like how we would solve a normal equation, probably with the exception of one step that we may have to do, because I see that this question is going for 3 marks, so I'm assuming that there's a little twist it at the end. So let's solve. So let me see, do I have space at the bottom? Yeah, let's solve it. So I'll solve it here. So I'll write it back. So we have 2x, 2 open bracket, x minus 6 plus 3x, and this is less than or equal to 8. We're asked to solve for this. So persons with me, when you have to solve this and you have a bracket and so on, what's the first thing you want to do?
Use the
Get rid of the
brackets.
bracket.
Get rid of the brackets, right? We expand the brackets. So from the time you see brackets, you want to expand them and get rid of them, right? So how can we get rid of the brackets? Using the distributive law. So this would be 2 times x would be 2x, and 2 times minus 6 would be a negative 12, and this would be plus 3x is less than or equal to 8. All right. So now there's a motto that I normally tell my students whenever we're dealing with algebra or anything as a matter of fact. Let me test them now. What is that motto? Put you out on the spot. As it relates to terms, you always do something.
Always group the like terms.
All right. That is a motto. Right? They always group the like terms. So we always group the like terms. So let's put the like terms together. So what is one important thing? If anything, if you leave this session tonight, this is one thing why I leave with, why I remember this thing. What is one important thing we must remember when we are grouping like terms?
So the sign must move with the number.
The sign must move with the number. Move with the sign in front, right? Whatever sign is in front of the number or the term, we move with that sign, right? So this will be 2x plus 3x. I mean, if you want, we can leave this minus 12 here. We can take it over one time. Let's take it over one time. So this 12 is minus, you take it over the inequality sign. The same thing that we do for the equal sign. The same thing we'll do for the inequality sign. So since this is subtracting, when we take it over to add. So this will be less than or equal to 8 plus 12. So now this will be 2x plus 5x, 2x plus 3x, sorry, that will be 5x. And this is less than or equal to, or should say greater than or equal to 20. And last but not least, we solve. We solve for x. So this 5 is multiplying. When we take it over the inequality, it will divide. So we'll have x is less than or equal to 20 divided by 5. Hence, x is less than or equal to 20 divided by 5 is 4. So this is our answer for x. Good. So I saw many persons that the answer is 4 before I got it, which is excellent, right? So the next part of the question says, let me erase this piece. Using a number line, show your solution in part A1. So we want to use a number line. Let me get the number line. Normally they would give you the number line, but in this case they didn't. So let's put a 0 here. 1, 2, 3, 4, 5, 6, -1, -2. So we want to represent this on the number line. So it says x is less than or equal to 4. So we are putting, when we want to represent solutions of an inequality, we're putting a circle over whatever the inequality is equal to. In this case, is 4. So you put in a circle over the 4. But I'm asking now, what do we have to do with this circle since it's less than or equal to? What do we do? Do we leave the circle just like this, or do we what do we do?
Sorry,
And
after
why?
Oh,
Sorry, go ahead, one. Yeah.
sorry, shaded
Why do we shade it?
because it's equal. It's also, it may be equal to 0. So 4, sorry.
So this equal to thing, it equal to sign at the bottom here, less than or equal to, we must shade it, right? So because of that, we must shade it. Now, when you shade, when it's solid or you shade it, that means 4 is also included in the solution. Because for inequality, it represents a range of solution. When you solve an equation, the answer is one number, or the answer is one thing. But for an inequality, it's a range. So this is saying the 4 is included in the solution as well. And since it's x is less than or equal to 4, which side do we go? This side or that side? Left or right?
Left.
You go left, right? Because left is less than. Of course, you see all these numbers here decreasing. It's less than 4, 3 is less than 4, 2 is less than 4, and so on. So we go point the arrow in that direction. And that is how we represent that. All right. Good. So the next one says factorize. So we're doing another factorizing question. And then I don't think I have any more factorizing. After this, we should be solid with factorizing. So we factorize when we had one term, we factorize when we had difference of 2 square, we factorize when we use the AC method. Now let's see what we do when we factorize when we have 4 terms. So let me write back here, we are factorizing 3x minus 6y plus ax minus 2ay. So we're factorizing this here. So the thing is, when we have 4 terms, you know, the easy thing, this is very easy to factorize. All we do, we pair off and then we factorize. So we pair off and then we just factorize each bracket. So we look at this first bracket, we see what is the highest common factor. We see 3 is the highest common factor. So we factor out 3 from the first term, we're left with x. We factor out 3 from minus 6y, we're left with minus 2y. We put back the plus. And then when we factor, we see, look at the next bracket, we have ax and 2ay. We see a is the A is the highest common factor, so we factor out A. And when we factor out A from AX, we're simply left with X. And we factor out A from negative 2AY, we're left with minus 2Y. And how do we know we are going correct? Again, we know we're going correct because the two brackets are the same. So as long as the two brackets are the same, that means we're going correct. So we just take what is outside and we put, this will be 3 plus A in one bracket and X minus 2Y in another bracket. And that is that. And the last one to factorize, we have, somebody saying something? And the last one to factorize, you have P squared minus 1. And I want to throw this one out in the chat. What method do we use here? We have P squared minus 1. Somebody said they're cooking. All right, so while we wait on them, let me give them 5 seconds and then I'll throw it out to my students on live with me. What do we do? And why? Anybody on the live with me?
There is a difference of two squares, so
Different.
so in one bracket we put P minus 1, and in the other bracket we put P plus 1.
All right, good. Excellent. So it doesn't matter if you put plus in this bracket and then you put minus here, it doesn't matter. As long as just one bracket you gotta add and the other one you gotta subtract. It doesn't matter the order. So don't try to cram the order and think, oh, which one is add, which one is minus. It doesn't matter. All right, it doesn't matter. All right. How are we looking? Are we cooking? We looked at a lot of factorization. How we cooking with the factorization or being cooked? So I'll answer. Let's move on. So this one says write as a single fraction in its lowest terms. So yes, okay. So write as a single fraction in its lowest terms. So we have x minus 2 over 3 plus x plus 1 all over 4. So we want to, basically what we do with these kind of questions, we work them just like how we would work a normal fraction. For example, we have a fraction where we are adding two fractions and we see the denominators are not the same. So what would we do when we have a case like that? We just find the LCM. We find the LCM of the denominators. So this will be the LCM of 3 and 4 would simply be, the LCM of 3 and 4 would be 12. And then we work this just like how we work a normal fraction. And that is the beauty about algebraic fractions. You work them just like how we work normal fractions. If it's it that you forget how to work, if it's it that you can't remember how to work these kind of things, well, you just put down a normal fraction on the side. And to refresh your memory, if you have 1 over 2 plus 1 over 4, you ask yourself, like, what do I do? I find the LCM of 2 and 4. And then what do I do next? I know I divide 4 by 2. I get 2 and I take that answer and I multiply the numerator. And then the same thing here. I divide 4 by 4 and I take that answer and I multiply the top here. So the same thing we have to do here. We divide 12 by 3 and we know that is 4. And we take that answer, we multiply the numerator, and the numerator here would be everything here. So we can't just multiply by the x, you have to multiply by every single thing. All right, so this would be 4 multiplied by x would be 4x. 4 multiplied by minus 2, that would be minus 8. And this would be plus. And then we do the same thing here, 12 divided by 4. You know, that would give me 3. So I multiply that answer here. This would be 3 multiplied by x, give me 3x. And 3 multiplied by 1 would give me plus 3. Then, of course, we do the motto. We do the motto as you learned earlier. The motto is we always, let me see if anybody can remember in the chat in you on YouTube. What is the motto? I know my students here will know it's the motto, but let me see if I remember the motto. The motto is we group the like terms. So we put the like terms together, so this will be 4x, and we put plus 3x minus 8 plus 3, all divided by 12. So we have 4x plus 3x, that will give me 7x. And negative 3 plus, negative 8 plus 3, that would give me a negative 5, all divided by 12. And this is my answer as a single fraction, all the marks. Group the like terms. And also carry it with the sign. Lovely, 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 lovely. So the person that said guy the motto, they probably joined, they probably joined late. Let's give them the benefit of the doubt. Not guy the motto, I'm talking about the motto for algebra. That guy the motto. But they probably joined late. So nice and easy. How much marks? How many marks is went for by? 3 marks. The 3 marks closer to getting this nice grade. All right. So let me tell you something about maths. While we the thing is you don't need to get everything right on this paper to get a grade 1, right? You just need to take your time and work it, take one question at a time. All right, so let's carry on. So moving on to some simultaneous equations. Grade 1. All right, so let's go. So simultaneous equation, we also solve the following simultaneous equations. Now, the important thing about simultaneous equation, regardless of which method you use, whether it's elimination, substitution, or even a matrix method, but most times you use elimination or substitution. So regardless of which method you use, the whole objective of solving simultaneous equations is to put one equation into the other somehow. All right, regardless of the method that we use, we just put in one equation into the other. So let's label this here. Let's call this equation 1, and let's call this equation 2. So the thing is, we see y by itself here, but this y got a negative here, man. A negative, like when you say a negative in front of a term, it's trouble, right? So we can't use the substitution method. Or we can use the elimination method. So in order to use the elimination method, as the name is in the method elimination, we want to eliminate one of the terms. So let's eliminate the x since it's right on the outside. So what we do, we multiply, we basically try to make these two terms the same. So what do? We multiply this entire top equation by this 3 here. And then we multiply this entire bottom equation by this 2 at the top here. So the entire equation we're multiplying. So this would be 2x times 3 would give me 6x plus 3y times 3 would give me 9y, and that is equal to 9 times 3 would give me 27. And then I multiply now 3x times 2 would give me 6x. Negative y times 2 would give me a negative 2y, and that is equal to 8 multiplied by 2, which is 16. Now, here's the thing. Students tend to, when they multiply, they just multiply these two alone and they forget about the rest, but you have to multiply the entire equation. You cannot just use one or two terms. The entire equation you must multiply by whatever we use here. So now that our two numbers are the same, we can eliminate them by just subtracting. So this will be, we subtract all of the like terms. This is the next step. So this will be 6x, subtract 6x. I put back the plus 9y, subtract. And we subtracting from this minus 2y. Minus 2y. So we need to be careful with that. Remember, this is a minus 2y here. So whenever we're subtracting from the minus 2y. We can't just say, oh, we got a subtraction here, so we can leave out this subtraction. No. This minus here is governing this 2y. And this will be equal to 27 minus 16. Here's the thing. Why I'll do something? If it's something in the video you don't understand, when the live done, bookmark the part and go back to the live and watch it back slowly, right? That is the best thing to do. Just remember which one you don't understand and then just go back to the live and watch it back slowly and it'll be, because when this video is done, it will be up, right? So now we work this out. So 6x minus 6x, that would be 0. And now we have 9y, sorry, 9y subtract negative 2y. So these two negative signs will cancel out. We got two negative signs together, meaning there's nothing in between them. I mean, so this will cancel and turn to a plus. So this will be 9y plus 2y, which would be 11y, is equal to 27 minus 16. That would give me 11. So hence y would be equal to, this 11 is multiplying, and we take 2, we'll divide, so we'll have 11 divided by 11. Y is equal to 1. So now that we have our value for y, now we can take this value for y. Remember, it's simultaneous. You have to solve both for x and y. You have to solve both for x and y. So to find the value for x, we take this y equal 1 and we put it in either equation 1, equation 2, or even any one of these equations. Doesn't matter. You'll get the same answer. So we'll say we'll substitute y equal 1 in, let's say equation 1, since that looks easier. Equation 1. So we'll have 2x plus 3 multiplied by y, but instead of y, we'll have 1 is equal to 9. And this will be 2x. So 3 times 1 would be plus 3 is equal to 9. So 2x would be equal to, so we solve this here now. So these kind of equations, regardless of what topic you're doing, you will always end up in a situation in which you will have to solve an equation like this, and you should be able to solve this here, like how you know, this is where we are not too good as young people. Anyways, whatever activity you know to do well, you should be able to solve this equation just like that. So how do we take over the 3? The 3 is adding, we take it over, subtract, so we'll have 9 minus 3. So 2x is equal to 9 subtract 3 would be 6. And then the 2 is multiplying the x, so we take it over to divide, so we'll have x is equal to 6 divided by 2, and x is equal to 3. So you can say, therefore, x is equal to 3, y is equal to 1. And we have all of our marks for this year. I mean, let me do a call on my people here, because I feel like they sleep way with on me. Akim, good? Feel like some of my students sleep way. Troy is there. Alia,
I'm good, sir.
I'm Reagan.
Sir, I'm still here, don't worry.
Okay. And Viviani, I see Viviani there. Kevin and Shaniko and Talia. Talia, you're in the comments.
Sir, I'm here.
Okay.
Yes, term everywhere.
Sir, I'm here.
Anyways, so we are we looking in the chat? We cooking or we are being cooked? Or the gas still burning? What kind of gas we cooking with? Blue gas, green gas stove, kerosene, fireside, candle. All right, so let's carry on. So we got a couple more with the algebra, and then we'll see how we feel after that. So it says Ali is X years and Jim is 5 years older than Ali, and Chris is twice as old as Ali. All right, so it's a comment kind of throw me off. Anyway, so write an expression in terms of X for Jim's age and Chris's age. So this is nice and easy to mark. So they said that Ali is X years old. Jim is 5 years older than Ali. 5 years older than Ali, and Chris is twice as old as Ali. So here's Jim. Jim is 5 years older than Ali. So if Ali is X, and we see Jim is 5 years older than Ali, so we see Jim's age will just be X plus 5. So all right, let me just say back, what do I mean in terms of X? When I say in terms of X, X should be the only variable inside of the expression. There shouldn't be any other variable. You can have numbers, you can have whatever sign, whatever operation, but X should be the only variable. That is what they mean by in terms of X. So the next one, Chris's age. So Chris is twice as old as Ali. So Chris is twice as old as Ali. So if Ali is X and Chris is twice as old as Ali, so Chris will be 2X. Seems a bit too easy, boy. It's a bit too easy. Anyways, 2 marks, nice and easy. All right.
Sir,
Yeah,
sir, someone's telling me they want to go till 6 a.m. here.
6 a.m. Who's there? Somebody saying that in the chat here.
No, sir, someone private messaged me because they're saying that they're having fun.
You're having fun? Okay. I'm glad that they're having fun. Maths is fun. Anybody else in the chat having fun? I am. I can go up until tomorrow is what, Sunday? Anyways, I'm glad that they're having fun. All right. Bye. Yeah, so the next one says, in 2 years' time, the product of Ali's age and Chris's age will be the same as the square of Jim's present age. So show that the equation x squared minus 4x minus 21 is equal to 0. All right, so I need people say they're having fun. Okay. But you see they got an Excel next to them. All right. I would encourage the Excel, but okay. So let me read back this question. So it says in 2 years' time, yeah, in 2 years' time, the product of Ali's age and Chris's age will be the same as the square of Jim's present age. So show that the equation x squared minus 4x minus 21 is equal to 0 represents the information above. So you basically have to represent this information that they gave us as an equation, and then we work it out so that we end up with this as the answer. All right, so you have to represent this. So yeah, I think we can represent this. They bold some words there. I'm hoping that is for a reason. So let's go. How do we represent this? In 2 years' time, they both in 2 years' time. The product of Ali's age and Chris's age, Ali and Chris, will be the same as the square of Jim's present age. So they both in 2 years' time. So in 2 years' time, how old will Ali be? Ali is currently X. In 2 years' time, how old will Ali be?
+2.
+2. And in 2 years' time, how old will who's the other person? Chris.
2x plus 2.
So it will be 2x plus 2. So they said the product of this is equal to, they said will be the same as, which means it's equal to the square of Jim's present age. So they bolded the word present for a reason, right? So Jim's present age is this, so they want the square of this. So this will be x plus 5. So we just need to pay attention. CXC doesn't want us to get the question wrong. So they bold some critical information. So we must pay attention to that. So we just got to work this out and we should get this as the answer. Well, this here as the answer. So let's work this out. So we got to use some distributive law. We got to use some plural distributive law here. So let's set this up. So to use a distributive law, when you have a bracket multiplied by a bracket, so what we do? So we take the first term in the first bracket. So this will be x, and we multiply it by everything in this bracket. So this would be, all right, hold up. Before I do that, let me just write back this bracket. X plus 2 multiplied by 2x plus 2. And let me simplify this part here. So x to the x plus 5 all raised to the second power. This is the same as x plus 5 multiplied by x plus 5. So we can't, some people would jump to this, right? The mistake that a lot of students would make. The mistakes that a lot of students would make is they would say, all right, everything in this bracket is squared, so what we'll do by x squared plus 25. That is absolutely wrong, right? It will be the bracket multiplied by the bracket, and you will not get this answer that we had here just now. Just be careful. So now we distribute. All right, so we take the first term in the first bracket, so this will be x, and we multiply by everything in this bracket. This will be x multiplied by 2x plus 2. And then we take the second term, which is plus 2, and we multiply by everything in this bracket, which will be 2x plus 2. And then this will be equal to, and we do the same thing over on this side. Take the first term, which is x, and we multiply by everything in this bracket, which will be x plus 5. And then we take the second term, which is plus 5, and we multiply by everything in that bracket, which is x plus 5. And then we work out now. This is the fun part. We distribute. So x times 2x would give me 2x squared. X times 2 would give me plus 2x. And then multiply 2 times 2x, that would give me plus 4x. And 2 times 2 would give me plus 4. And hence this will be equal to, I do the same thing here. The x times x would give me x squared. And x times 5 would give me plus 5x. And 5 times x would give me plus 5x. And 5 times 5 would give me plus 25. So we had a lot of terms here. It's just for us to simplify now. So you simplify. Yeah, we simplify. So we put the like terms together, but first let's simplify this side. So we have 2x plus 4x. That would be 2x squared. So 2x plus 4x, that would simply give me plus 6x. And this would be plus 4. And that is equal to x squared. Yeah, even that slow, it would be kind of blurry. So this would be x squared, and we put now 5x plus 5x. So this would be plus 10x. plus 25. And now, remember the whole objective of this thing is to work out so that our equation is this here at the top here. So now let's put everything on one side of the equation. Let's put everything on one side. Let's carry over all this here on this side. All right, so this will be 2x. So let's 2x squared. So let's carry over the x squared term. So this is adding when we take it over, we'll subtract. And this will be plus 6x. Now let's carry over this 10x. So this plus 10x, when we carry it over, it will subtract. And then you put back the plus 4. And now let's carry over the 25. So we carry it over, it will subtract. So subtract 25. And this is equal to 0 because we took over everything. And now let's finish off the question. So 2x minus x squared. That will give me x squared. Six x minus 10x. That will give me a minus 4x. Then I have 4 minus 25. That will give me a minus 21. And this is equal to 0. So hence, this is the answer. All right, this is the answer. We had to do a lot of work. Go ahead, Amber.
Sir, could you please go through it?
All right, yeah. Let me. All right, so let's do it back. Let's go through one more time. All right, so yeah, pay attention. Pay attention. You got a second chance of understanding. But it's very easy though, man. All right, let me start from the beginning, right? So let me highlight, let me use my highlighter. So it says in 2 years' time, so they bolded 2 years. So they said in 2 years' time, the product of Ali's age. So we know Ali is X years old, right? So if Ali is currently X years, in 2 years, Ali would be X plus 2. So it's X plus 2. That's how we got this X plus 2. Everybody should be with me there, right? So they said that Chris's age. So Chris's age, Chris is currently 2x years old. So in 2 years' time, Chris will obviously be 2x plus 2. Those I end up with this 2x plus 2 here. All right, that is currently 2x age, 2x years old. In 2 years' time, we just add on 2. So they said the product of those two things, the product of Ali's and Chris's age. So that is why we multiply x plus 2 multiplied by 2x plus 2. That is why we have this multiplication here. And they said this will be the same as the square of Jim's present age. So currently Jim is x plus 5 years, as we found earlier. And they said it's a square of this. So that's why we square Jim's age there. All right, so that is how we got this equation here. And now the other part is the algebra. So if this part troubling you, that means you need to go and revisit how to use the distributive law. But I go through it though. All right, you gotta know how to use the distributive law. So what I did, I just expanded this here, x plus 5. I just expanded it. This square means it's x plus 5 multiplied by x plus 5. So that's how I ended up with this here. And then I use some distributive law. So what I do, in order to use the distributive law, let me zoom up to this piece. In order to use the distributive law here, you have two brackets multiplying each other. So what do? I take the first term, which is x, and I multiply it by everything in this bracket. That's how I end up with x multiplied by 2x plus 2. And then to distribute this thing fully, I go now to the second term. And once again, I multiply by everything in this bracket. So there's I end up with 2 plus 2 multiplied by 2x minus 2. So that is how I ended up with this part here. And then over on this side now, I do the same thing. I take the first term and I multiply by everything in the second bracket. So as I ended up with this. And I take the second term and I multiply by everything in the bracket again to distribute this thing fully. And then now it's just to use the distributive law like how you should know how to use. So we distribute, so it's x multiplied by 2x, that'll give me 2x squared. Then it's x multiplied by 2, that'll give me 2x. Then it's 2 multiplied by 2x, that'll give me 4x. And then it's 2 multiplied by 2, that will give me 4. As I ended up with that. And then it's x multiplied by x, that'll give me x squared. X multiplied by 5x. X multiplied by 5, that'll give me 5x. And then 5 multiplied by x, that'll give me 5x. 5 multiplied by 5, that'll give me 25. So that is how I ended up with this piece. Then now, I just put the like terms. I just bring over all the terms on one side. Actually, before I did that, I added some like terms. So 2x plus 4x, that will give me 6x. And then I added 5x plus 5x, that will give me 10x. And then I brought over all the terms on one side. So I have 2x squared. I have x squared here. And I carry this over to become 2x squared minus x squared. And then I put back the plus 6x. And then I carry over the plus 10x, it will become minus 10x. And I put back the plus 4. And then I carry over the plus 25 to become minus 25. And all I do now, I just simplify from there. 2x minus x squared, I end up with x squared. 6x minus 10x, that would be minus 4x. And 4 minus 25, that would give me negative 21. That is equal to 0. And I'll have all the marks here. How many marks did this question go for? Oh, I cropped out that piece. So probably about 3 or 4 marks. How are we looking now? We cooking now? So these show questions, right? Let me just say this. These questions are telling you to show. You're basically working towards that answer. You're simplifying, you're multiplying, dividing until you get this answer. All right, so my computer battery is dying. Let me just unplug it in quick, put the live in. Well, so let's carry on now. You might say 3 marks, so 3 marks is plenty marks in CSEC. 3 marks can determine if you pass or don't pass, right? So let's go solve for x, where x is a real number. So this one is a nice one. Pass your bedtime. So we are solving for x. So let me zoom up. So we did one like this just now, so we'll do the same thing. So we put let's bring over all the x's on one side. So this will be, so this is a minus x, so we'll have minus x, and then this is a plus 5x, so this will become minus 5x is less than or equal to. And we have 2 here. And we carry over this 8. This is a plus 8. When we carry it over the subtract, so subtract 8. So now we have negative x minus 5x. That would be a negative 6x less than or equal to. And 2 minus 8, that would be a negative 6. And this is a big part. How many marks this question is worth? This part here now is a part that many students may fumble, but you would not fumble because you are a part of the couple students, the 100+ students, the hundreds of students paying attention to this live, and you will get this question mark when it comes, or I should say if it comes in the exam. Now we have this negative 6x, we are solving for x, and we have this negative 6 multiplying this x, and we want to carry it over the inequality. So the thing is, when you carry over a negative, and it has to either multiply or divide, you must flip the inequality sign. So because this negative 6 is multiplying, we carry it over, divide, we'll have x, and now we must flip this inequality sign because it will divide when it goes over here. So it will be, instead of the inequality sign being like this, it will flip around and come like this. This will be negative 6 over negative 6. So x will be greater than or equal to, is negative we cancel out, and 6 divided by 6 is 1. All right. So as long as you have to multiply or divide by a negative, you flip around the inequality sign. So you're a part of the hundreds of students who, if you didn't know that, now you know this, right? So a question is asking, how to pass maths without doing any work? All right, so this, I'm not sure if they wanted to source that on YouTube, but won't be able to advise you how to pass maths without doing any work, right? Anyway, so that is how we get that answer. So the next one says, represent your solution on the number line below. So once again, we see we got to put a circle over 1. And because of this equal to at the bottom here, we have to shade the circle. So, and its x is greater than 1. So because it's greater than which side, we go in right or left? Now, where everybody, we're going to the right, right? Going to the right. And that would be our 1 mark for this diagram question here. Nice and easy. Let's go. This one now. Expand and simplify. So when it says expand and simplify, we're just expanding and simplify as the instruction says. Now, when people say the first part in answering any question, must understand what the question is saying, right? So don't go and solve and so on. I honestly know some students will go and they will equal this to 0 and then they will solve. No, do what the question is asking you to do. Expand and simplify. Don't complicate things by solving and so on. Just expand and simplify. Let me work this here. So to expand this would be 2x times x, which would be 2x squared. 2x times 5 would be 2 times 5 would be 10. So this is 10x. And then I multiply this negative 3. So negative 3 times x, that will be negative 3x. And negative 3 times negative 4, that will be plus 12. And now we do the simplifying part. And for those of you who joined since the beginning, when we are simplifying, we always move with the sign in front. So this will be 2x. We put the like terms together, and that is the motto. Oh, the like terms are already together. So this is 10x minus 3x. That would be plus 7x plus 12. And this is our answer. Nice and easy. 1 or 2 mark. We have 2 more algebra questions, then we move on. How are we looking? How are we looking? We cooking? My students here, we cooking or are being cooked? I actually be cooking up here.
Cooking, sir,
Be
cooking.
cooking.
Sorry, the only thing that's not getting cooked at this point is my dinner.
Okay. Yes. All right, how are we looking at the chat class? We cooking? Cooking, lovely. Somebody saying good. How long? How long is the session? How long is the session? I don't know. Whenever we finish, whenever we feel like stopping. All right, so let's go. I said the cook till it's born. No, when it's born, it's done. Right? The food burning. I gotta take it out. Anyways, let's go. Let me not worry the chat. If I already chat, we won't do any maths. Okay. So let's go. By them learning the slangs of the young people, right? So students are keeping me in the loop. Anyway, so it says solve the equation. Oh, hence solve the equation. Why did it say hence? There's a question before. Anyways, let's solve it still. We want to do bearings. I want to bearings. I understand algebra was for do bearings. Let's see the do bearings just now. So let's go. Let's solve this here. We didn't do any solving of any algebra quadratic, so we'll solve this and then we'll move on to another topic. All right. So let's go. So we have x squared. So before we can solve this, let's put the like terms together. Let's bring over everything on one side. I'll work this one. Troy, you want to work this one?
Sure, sir, sure.
Okay. Go ahead, Troy. Sorry, my bad.
So like first, sir, we equal everything to 0. So it'll be x squared minus 6x minus x plus 8 plus 12 plus 2 equals 0. Yeah. Then we use the AC method. It would be A is 1 and C, oh, sorry. So you combine them, right? You add the like terms, you'll get x squared minus 7x plus 10. Yeah. Then we use the AC method. First, you have to find what is A, B, and C. A is 1, B is -7, and C is 10. So we do AC, which would be 1 times 10 will give you 10. So you find two numbers, when you add them, you get -7. When you multiply them, you get 10. So then two numbers would be -5 and -2. So -5 times -2 would give you 10. And -5 plus -2 would give you -7. So sir, now you put it in the equation. It will be x squared minus 5x minus 2x plus 10 equals 0. And now you bracket off x squared minus 5x and -2x plus 10. So now, sir, you find a number that could factor out x squared minus 5x. That number would be x, or 1. So now you get x minus 5 in bracket. And then you use -2 to factor the other bracket, which will give you x minus 5 equals 0. So now you write x minus 2 in one bracket and x minus 5 in other bracket equals 0. And now you find for x. So you have x minus 2 equals 0. This will give you x equal 2, since when you carry over the negative 2, it becomes positive. And then x minus 5 equals 0. And x equals 5. Yes, sir. Therefore, x equal 2 and x equal 5.
Let him cook. Somebody say, let him cook. Let him cook now. Let him cook. Anyways, we left text bolts in 2025. Oh, I know how we know that. That's up to date. Anyways, all right. So well done, Troy. Well done. 2024. Okay. Well done, Troy. Well done. Well done. Nice and easy. You could have also used the quadratic formula or your factorize, right? Excellent. All right. So we now will move on to somebody asked me when we finish. You know, CX season 40 days when you finish. Yeah, we should be going up until midnight. Let me ask my students, are you tired? Not tired? Anybody tired in the chat?
No, sir.
No. Somebody said Troy the goat. All right, Troy. All right, so let me just open the other document and then we will. So let's see. Let's give the poor people in the chat which topic I want us to do next. The loyal ones who are here from the beginning. Which topic should we do next?
Functions.
Functions?
Yeah.
Let me look for functions. All right, good. The functions. Yeah, let's do functions. All right, so let's go. So good. So let's do some functions and some variations as well. Nice questions. So let's go. So anybody want to tackle the first one? Anybody would like to cook? All right, so I'll do the first one and then I'll leave the floor open for anybody to work this one, right? So I think about that in the meantime. So it says the functions f and g of x are defined as, and we have f of x is equal to 2x minus 7 all divided by x, and g of x is equal to the square root of x plus 3. So we want to evaluate f of 5. So let me write back the functions. We have f of x is equal to 2x minus 7 all divided by x. And they want us to evaluate f of 5. So some people could work this mentally and get the answer. So f of 5, we basically substitute in wherever we have x, we put in 5. So instead of x here, we put in 5. Instead of x here, we put in 5. So this should be 2 multiplied by 5, subtract 7, all divided by, instead of x, it will be 5. This will be 2 5s, 10. 10 subtract 7 would be 3. 3 over 5. So f of 5 is equal to 3 over 5. Nice and easy, 1 mark to get the blood flowing in the exam. I always want to get the blood flowing. It's a nice and easy one. Good, so let's move on to the next one. So I'll hand this over now to somebody, one of my students who is on here. Who would like to,
Sir, can I take it?
right, so we have Kevin. So Kevin, let me just write back so we have so let me just copy this and then I'll allow you to. Yes, Kevin, the floor is yours. Go ahead.
All right, sir. So for the first step that we do, replace f of x with y. So that would be y equals to 2x minus 7 over x.
Hold on, just give me a sec. Let me just, sorry. Go ahead, Kevin, sorry.
All right. So the first step, replace f of x with y. So y equals to 2x minus 7 over x. Then wherever in the equation we have y, replace that with x, and wherever there's x, replace that with y. So x is equal to 2y minus 7 over y. Then we make y the subject. So first we'll multiply both sides by y. So we'll get xy equals to 2y minus 7. Now we bring over the 2y. So that'll be 2y minus 2y. No, xy minus 2y equals to minus 7. Now we take out the y, so that'll be y, open brackets.
When you say take out, what do you mean?
Okay, so wait, I forgot what's the technical term for that, but
D is with F.
factorize. Yes, factorize. So factorize the left-hand side by y, so that'll be y, open brackets, x minus 2 equals to minus 7. Now finally, we can divide both sides by x minus 2, so that'll be y equals to minus 7 over x minus 2. And now we're not done yet, so now replace the y with f inverse x equals to minus 7 over x minus 2.
Let him cook. All right. Not bad, not bad at all, boy. We cooking, we cooking. Did Kevin cook? That's a well done, Kevin. All right. So, all right. So next one, we want to find GF of X. So who's taking that one? GF of X. Any volunteers? All right, let me see. Let me work it. Let me see if we can work it. So for GF of X, we're taking the function F and we're putting it inside of G. We're taking the function F and we're putting it inside of G. So basically taking this function, we're putting it inside here. How are we putting it? Wherever there is X, we replace it and we put in this function here. So this will be the square root of Instead of x, we'll have 2x minus 7 all divided by x plus 3. So this will now be the square root of, we can simplify this. Let's simplify this a bit further. So let me just copy this and paste this in a nice big space. So we can simplify this. So we have 2x. So we have 2x minus 7 over x plus 3. So this plus 3 is the same as plus 3 over 1. So let's just combine these here to get a nice equation. So this will be the LCM between x and 1 would simply be x. So x divided by x would be 1, and we multiply the top a by 1, which will be the same as 2x minus 7 plus x divided by 1 would be x. So we multiply this answer here by x. This will be plus 3x. And then this will simplify to put the like terms together. So this will be 2x plus 3x minus 7 all divided by x. So 2x plus 3x, that would be 5x minus 7 all divided by x. All right, so hence, when we work out this, answer would be 5x minus 7 all divided by x, the square root of all of this. So g f of x is equal to this. All right, so we just have to substitute and then simplify. All right, nice and easy. And this here went for like 6 marks in total. So let me just erase this. So these two here went for 6 marks. And the one that Kevin did, these are, he followed steps, right? When finding inverse of any function, step 1, you change the f of x to y, and then you interchange the x and the y, and then you make y the subject of the formula. 3 simple steps. All right, so next one, 3 marks. Anybody would like any takers for this one?
Sir, I think I want to attempt it.
Give me 1 second. There you go ahead, right?
Okay, sir.
Yeah, Amber, go ahead. Let me mute. Read the
Okay.
question, all right?
Express the quadratic function 1 minus 6x minus x squared in the form k minus a, open brackets, x plus h, close brackets square, where a, h, and k are constants. So basically, h and k is the vertex of the parabola, and this is the vertex form of a quadratic function. So we basically have to go with the formula. And they gave us a formula, which is k minus a, open brackets, x plus h, close brackets square. So h is equal to b over 2a. And k is equal to c minus b squared over 4a. So for h, we can substitute because b equals to -6 and a equals to -1. So h is,
Identify what is A, B, and C for us.
oh, sorry. B is equal to -6, A is equal to -1, and C is 1, positive 1. So H is equal to -6 over 2 in brackets -1. So H is equal to -6 divided by -2, which is equal to 3. Hence, the value of H is 3. As for K is equal to C minus B squared over 4A. And that basically means 1 minus -6 square over 4 in brackets -1, which is k equals to -1 Well, no, not minus 1. K is equal to 1 minus 36 over negative 4. K is equal to 1 minus negative 9. And K is equal to 1 plus 9, which is 10. So the value of K is 10.
Sorry, repeat that more, sorry. Repeat the
Wait.
last piece.
K is equal to 1 minus negative 9. And K is equal to 1 plus 9, which is 10.
All right, so it's my fault, all right? This is 36 divided by negative 4. So this is equal to 1 minus 36 divided by negative 4 would be a negative 9. This is how I write, right? Sorry. So hence K is equal to 10. All right. Says Amber, sorry, finish it off.
Therefore, H is equal to 3 and K is equal to 10. But if we write that in a form, wait, so give me a second.
Well, Amber is thinking, right? So all we did, this is the formula. The thing is, you're not given this formula. You need to remember this formula, right? This is the formula that you use to find for H. Because they want you to write this thing in this form. Right? They want you to write it in this form here. All you need to do is remember this formula for H, and you remember this formula for K. And then you just identify, this is a quadratic as well. So all you do is identify A, B, and C. In this case, the value of A is -1. The value of B is -6. And the value of C is the number by itself, which is 1. Right? So all you need to do is take these values here for A, B, and C, and you substitute them into the equation for H and K. That's all you need to do. Substitute the values for A, B, and C into these two equations that you must remember. You will not be given this, right? So this is the form they want you to express it in. K minus A, open bracket, X plus H squared. So we found for K by using this formula. And then we found for H by using this formula. So that's what we did here. That is what we substituted here to find. Right? That is all we did. That is all we did. This is all we substituted to find. So we found K. Yes, I'm more. Finish it off.
Y is equal to 10 plus open brackets X plus 3 close brackets square.
All right, so this is the form they want you to write it in, right? So what we did, we found our value for K. We found K being equal to K being equal to 10. So wherever we have K, we put in 10. And then we minus wherever we have A, we put in our value for A, which we found here to be this -1 here. The A is -1. And then X is always X, we don't change X. And then h, we found h to be this tree here. All right. So we put in h for 3. And then now we simplify it so that it looks like this. So we know this would be 10 negative, well, 10 minus negative 1 would be the same as 10 plus 1, open bracket, x plus 3 squared. All right, and this is our answer. Yeah, there's another formula you can use as well, 4ac. So the another formula you can use is 4ac minus b squared, all divided by 2a. That is another formula as well, right? But this here is a same thing as that formula. This formula here is the same thing as that, but it's just that this one is simplified a bit further. So I would advise y'all, remember these two formulas because you won't be given them in the exam. Remember these two formulas and you're good to go. Remember these formulas and just know to identify A, B, and C for a quadratic and you're good to go. All right, let's see what else we can move on to. Let me see, let me move on to the next one. All right, let's do some other functions. So it says a function h of x and g of x are defined as, now we have h of x is equal to 10 over x, subtract 3. Anyway, good job, Amber. You cook a little too much. But good job, good job. You cook a little too much. But very good, very good. Quick. So the function h of x and g of x are defined as, we have the function h of x 10 over x minus 3, and we have g of x is equal to 3x minus 2. And we want to evaluate g of 4 and hg of 4. So let me just go through these ones here quickly. So g of 4, so we basically take in 4 and we substitute it inside this function. That's why it's 1 mark. So g of, so instead of g of x, we'll say g of 4 is equal to 3 multiplied by 4 subtract 2. So 3 times 4 would be 12 minus 2, which is equal to 10. So g of 4 is equal to 10. And the next thing they want us to find is hg of 4. So what we're doing, basically taking g of 4 and we're putting it inside the function h. So we're taking g of 4 and putting it inside the function h. But the beauty of this question is that we just found g of 4. We just found g of 4 to be equal to 10. So instead of finding a g of 4, we can basically replace this g of 4 with 10. All right? So we already know the value for g of 4. So hg is g of 4 will be the same as h of 10 because g of 4 is equal to 10. So all we need to do now is find h of 10. So h of 10 is simply equal to 10 over, instead of x, it will be 10 over 10 because we are substituting 10 inside, subtract 3. So 10 over 10 is 1, subtract 3, which is a negative 2. So h of 10 is equal to a negative 2. right? Space at the top. Let me carry these workings at the top here. The next thing they want us to find, they want us to write expressions in x for h inverse of x. So h inverse of x. So this here, we're finding the inverse of this. So step one, we replace h of x with y. So this will be y is equal to 10 over x minus 3. And then step two, we interchange the x and the y. So we'll have x is equal to 10 over y minus 3. And then the last step, we make y the subject of the formula. So we take over this 3 subtract, we take it over add, so we'll have x plus 3 is equal to 10 over y. And the y is divided, we take it over multiply, so we'll have y multiplied by x plus 3 is equal to 10. And then remember the objective is to make y the subject, so this here is multiplying, and we take it over divide, so we'll have y is equal to 10 divided by x plus 3. And then remember we wanted to find h inverse of x. This would be h. We replace y with the inverse function, which is h inverse of x is equal to 10 over x plus 3. And that is the answer, nice and easy. 2 marks. 2 marks closer to the goal. How long have we been live? Feels like 5 minutes. How long has it been? Have we been live for 5 minutes? Feels like 5 minutes. We all know. Troy, Amber, Talia, Kevin.
10 minutes, sir.
Talia. 10 minutes? Oh, 10 minutes. We've been live for 10 minutes?
For approximately 9.5.
9.5 minutes? Okay. It feels like that. All right. As you can see, all of us on the live here, we are lovers of mathematics. So I will advise y'all, any part you're not clear with, the live will be up. You can always go back and look through and work it out slowly. It should be 10 here. All right, so the last part for this question, we want to find GG of x.
Yes, sir.
So GG of x, so let me just write back the function g of x to g of, let me work it right here.
Sir,
So you want to, go ahead, Alia, so let me write it, all right, go ahead. Let me write back the function g of x is equal to 3x minus 2. I want to find GG of x. Go ahead, Alia.
Okay, to find GG of x, we're putting g of x into g of x. So that would be 3, and in bracket, we're going to put back g of x. So it's 3, open bracket, 3x minus 2, close bracket, minus 2. And then now we get rid of the bracket. So 3 times 3x is 9x. And 3 times minus 2 is minus 6. Minus 2. Now negative 6 minus 2 is negative 8. So now we write back 9x minus 8.
Right, very good. Very good. Nice and easy question. 9x minus 8, just put g inside of g. All right, excellent. A nice and easy 2 marks there as well. So if you got all of these correct, you got 6 marks. Nice and easy. Good. Somebody saying in the chat that we are live for 2 hours and 12 minutes. I don't believe that, man. It's 10 minutes. Always probably 11 minutes. All right, so I have another function questions here, a different type of function question. So anybody want to work this one? All right, let me work. You want to work it?
Yes, sir.
All right, go ahead. You read the question and work, right?
So the functions are from the top or just see?
Yeah.
The functions f, g, and h are defined as follows. F of x equal 4x minus 1, g of x equal x squared minus 5, and hx equal 3 to the x power. So find g of x minus 2 in its simplest form. So it will be g of x minus 2 equal to x minus 2 squared minus 5. Yes, sir. So now you expand. So it will be x minus 2 times x minus 2. Yes, so now x times x will give you x squared.
Sure, let me do this step in which we set it up. Make sure you don't make any mistake.
So you're talking about the arrows or this? Yeah.
Yeah, you put the take the forest storm and so on.
Yeah. X times x minus 2. And then you have 2 times x minus 2.
-2 or -2.
Yes, sir. So now x times x give you x squared. X times -2 give you negative 2x. Now negative 2 times x will give you negative 2x. And negative 2 times negative 2 will give you plus 4 minus 5. So now you could be like terms, and you'll get x squared minus 4x plus, when you subtract 4 or 5 from 4, you get negative 1. So g of x minus 2 equal x squared minus 4 minus 1.
Very good. Very good. Let me see. We got who in this chat, who in the on the Zoom then in cookers yet. Everybody gotta eat. Somebody gone. Anyways. Good. So yeah, nice and easy.
Sir, Troy
Yeah.
cooked so hard, I actually got my dinner.
Okay. Finish eating?
No, sir.
Okay. All right. Somebody say when I gave it, now we finished. All right, so let me see. 2 hours. You've been live for 2 hours. Let's see. Let's carry on. Let me see what else we have here that we didn't do. Let me see another type that we didn't do as yet. Uh-huh. We did one like that, did one like that. All right, I like this one. We didn't do any like this for the night. Talia, Talia, the people are asking for you. People in chat say they want Talia to cook.
Words
Talia.
for retaliate with.
All right, let me not put Talia in the spot. If Talia wants to cook, she'll cook.
Think Talia gonna sleep.
Ah. Anyway, so the question says, the diagram. All right, no, never mind. This is too easy. We did one like that already. All right, so let me stop sharing and then let me see what else we can do. Let's go to vectors. Everybody say they love vectors. Let's go and do some vectors. Vectors question. Remember, you going till Martin, right? Troy, Amor, Kevin, Alia, Viviani, Kevin, Akim. Wait, Akim, again.
They
Okay, just checking. All right, so let's move on to some vectors and matrices, right? So everybody that was asking for vectors and matrices, all right, we're not going till morning, most obviously. Let me start off with a nice and easy question with vectors and matrices. Or do this every day, we getting grade 1. Now we gotta do this every day. You can do this every day though, by working papers. All right, so let's move on to some vectors now. Let's start off something easy to get the blood flowing. By the way, let me just do a quick check in the chat. Let me see this the schools. Type your school, the school that you're from. Let me see who are the schools that endure until 2 hours later. I saw some earlier. Let me see those of you who are still here. So send your school in the chat. Let me see which school we have in the chat.
I hope to see a lot of people from St. Rose's on this live.
Okay. Apex, 8 Mile, QC, PKSS, Ijeval, Fort Wellington, East Rumville, Covent Garden, Annandale, Wakapow, Tutorial, Skeldon Line Park, QC, Kenzie, Kokwani, Apex, BHS, there's a Bishop's High, Barbies Education Institute, Christchurch, Matthews Ridge, all right, Diamond, Apex, Quarantine,
Is
Port
Bishop's.
Kaituma, JC Chandy Singh, Port Kaituma, Barbies, we had a lot of Barbies people here. Hope, Christchurch, I said it's just joining where they are at Mandir, okay. Ijeval, Bishops, West Dem, Anna Regina, all over Guyana, the Stadio, St. Winifred, St. Roses, Blackbush, okay. Tutorial, New Silver City, Modern Academy, Tutorial, Multi, Port Kaituma, St. Winifred, Saints, Camille's, okay. Barbados, okay. We into Barbados. Are we the side vectors or something like that? Viviani, I sent you a message here. Copy it and send it to everybody for me. Sorry. That was an accident.
Okay, sir.
All right, so let's go. So vectors. So the diagram below shows two position vectors. So the diagram below shows two position vectors, OR and OS, such that such that um such that such that R is 6, 2 and S is -4, 3. So here's the thing, position vectors mean we start from the origin. We start from the origin and we go to whatever point, right? Position vectors start from the origin. That is all we need to know. And whenever we want to write position vectors in whatever, whatever coordinates they give you, just write it in vector form, right? Position vectors are very easy to express in vector form. So the first thing they want to write as a column vector in the form xy, which is in the vector form, OR. So OR, the point R is 6, 2. So OR, without a diagram, we know OR would just be, we just turn this 6, 2 into vector form. So this would be 6, 2. Or another way you can work this out would be, we move from O to R, we jump across, we move across, and then up. So we see to move from O to R, we move across 1, 2, 3, 4, 5, 6, and then we go up 1, 2 times. So it's 6, 2. So that is a vector OR, nice and easy. And next thing we want OS. So to find OS, we see the point OS is simply -4, 3. So to get OS, we know we can just write it as -4, 3 like that. Or since we have the diagram, we know we can just move from O to S. See, we see go across 1, 2, 3, 4 times to the left. That is how we end up with this -4. And then we go up 1, 2, 3. So that would be OS and OR. The next thing they want SR. I want to hand this one over to who want to find SR. I'll hand this one over to let me work. So next thing they want us to find SR. So here's the thing, SR, so we want to move from S to R. So there's a law called the triangle law, and in order to find SR, we can use that triangle law. Triangle law basically says to move from S to R, we can move along a triangle. So we can move from S and we can go to O, and then we can move from O and we can go to R. So basically to find SR, we move from S to O plus O to R. So to move from S to O, we see to move from O to S is -4, 3. So to go in reverse from S to O, we just flip the signs to whatever is here. So instead of -4, 3, it will be +4 and -3. Because instead of moving from O to S, we're moving from S to O. We're going in reverse. So the signs must reverse. So this should be plus. We see OR. We already found OR at the top here to be 6, 2. This will be 6, 2. So to finish this off, this would be 4 plus 6 would be 10. -3 plus 2 would be a -1. So SR is equal to 10, -1. And that is how we find SR. St. Ignatius, Santa Rosa, all right. Glad to see all of you are still locked in. Is that a term I use now? Teenagers locked in. Where are the teenagers? Troy? That is a saying I'll use now, locked in.
Yes, sir.
Okay. So yeah, that is how you find SR. Nice and easy, right? Just move along a triangle. So the next thing they want us to find the magnitude of OS. So we know OS is equal to -4, 3. We're getting this info locked in. Anyways, so to find the magnitude of OS, the formula to find the magnitude of OS to be the square root of x squared plus y squared. We are talking about 4, not 3. Anyways. So to find the magnitude of OS, it's the square root of, oh, here's the thing, that this top number here is x, and this bottom number here is y. So all we do is substitute these values into the formula. So all we do is substitute these values into the formula. So it's the square root of, now instead of x squared, we'll have the value of x, which is -4 squared, plus y, which is 3 squared. So the magnitude here would simply be, when we square -4, it will be 16 plus, when we square 3, we get 9. So this would be the square root of 16 plus 9 would be 25. And therefore, the magnitude of OS would be, when we square 25, you will get 5. So the magnitude is 5 units. Right, so we just use this formula. And this formula is similar to the Pythagoras' formula. And there's a proof to show that. But yeah, this is one of the formula you want. I think, is this given to you? I think this formula is given to you in Csec. I think. 60% sure, 70% sure this is given to you. So yeah, that is how we find OS. So let me just go back to this question because I think this is a very nice question. Somebody's asking, why do I use SO instead of OS? Because I'm moving from S to R, and the triangle law says in order to move from S to R, I can complete the triangle and it's going in the same direction. So I start from S and then I move from S and I go to O. That is why I have SO. I didn't move from O to S, I moved from S to O. And then from O, I move to R. Thus I end up with OR. So here's the thing. If this giving you trouble, I got plenty videos on YouTube that I did with this, plenty. Just go back and watch this. They're about 4 minutes long, in which it's me explaining the concept. So just go back on YouTube and look at them, right? There are plenty. Or I think I have plenty, yeah. All right. So yeah, if this giving you trouble, go back and visit those videos. Very simple stuff. As long as you understand, you're good to go. All right, so I like this one. So it says given that OT is equal to 25, prove that OSTR is a parallelogram. I'm predicting that a lot of people say, oh, sorry, they don't get this one. But this one here is, you gotta understand a few things before we go into this, right? So I'll answer the question. And once again, if this is giving you trouble, I'll advise you to revisit some videos that I have on my channel in which I work um, parallel vectors and collinear vectors, right? So in order to prove that OSTR is a parallelogram, now here's the thing. What do we know about a parallelogram? We know that for a parallelogram, the sides the opposite sides are parallel. So let's say I have OT is equal to 2, 5. So let me go back to this diagram. So OT is equal to 2, 5. So I can get 2, 5. So I can go 2 across, 5 up, 1, 2. 1, 2, and 5 up. 1, 2, 3, 4, 5. So here would be T. So if I want to prove that this is a parallelogram, I must show that ST, I must show that ST is parallel to OR, and I also must show that OS is parallel to this one, this vector here, RT. All right. So in order for me to show what the axis show that OSTR, so let me write this at the top here. OSTR, they want me to show that this is parallel. So in order for it to be a parallelogram, the opposite sides must be parallel. Right? That is one of the properties of a parallelogram. The opposite sides must be parallel. So I must show that this side here is parallel to this side. And let me ask the question now to my students on the call, on the live with me. How do I know when two vectors are parallel? Everybody can. How do I know when two vectors are parallel? With my everybody sleeping? Me.
Sir,
Yeah.
we know two vectors are parallel when one is a scalar multiple of the other.
But then one is a scalar multiple of the other. All right. The two vectors must be, one must be a scalar multiple of the other, then they are parallel. Good. So let's look at ST and OR. So the vector ST is equal to, we go 1, 2, 3, 4, 5, 6 across, and then we go 1, 2 up. So the vector ST is equal to 6, 2. And the vector OR is equal to 1, well, 6, 2 as well. But ask if we can touch 3 hour. So we see, are these two vectors a scalar multiple of the other? Well, is one a scalar multiple of the other? Can we multiply any by a scalar? Yeah, right, you see OR is equal to ST. We can say 1 STR if you want. Right? So OR is equal to ST. You know, one is a scalar multiple of the other. If you multiply OR by 1, you will get ST. Right? And let's look at OS. You see, OS is, we found OS to be negative 4, 3. And we found RT, we don't know what RT is. So to find RT, we go 1, 2, 3, 4 across. 4 in the negative, and then we go 3 up as well. 1, 2, 3. So we see OS is equal to RT as well. So because of these properties, so we can say therefore, because OR is equal to ST and OS is equal to RT, we can conclude that QSTR is a parallelogram. QSTR is a parallelogram. All right, guys, so we show that they are parallelogram. We want to show that the vectors are parallel. And how do we show that they are parallel? If one is a scalar multiple of the other. As long as they are a scalar multiple of the other, they are parallel. And because the opposite sides are parallel, they are parallelogram. Right? So if this one was troubling, I will advise once again, look over parallelogram. Not parallelogram, no. Parallel vectors. I have a video on with parallel vectors. I have a feeling I'm alone on here. Viviani, I'm more y'all tired? It's okay if y'all
Yes, sir.
tired. But y'all not tired?
No,
Kind
sir.
of.
It's
It's
just begun.
All right, let's end off with an easy question. Let's end off with an easy question and then we'll call it George. Let's end off with this question. All right, we'll see when we'll come again. We touched a lot on algebra, we touched a lot on functions, and we touched some on vectors, and now we looking at a matrix. So after this, we'll call it George. Anybody was here from the start? Let me see. Let me see the persons who are here from the start. If you're here from the start to the end, comment me and yeah, just say me. Let me see who's here from the start. And if you want Talia to cook, say let Talia cook.
Where?
If you
Let
want Talia
Talia
to
cook.
Let Talia cook.
if you want Talia to cook in the chat, let's say let Talia cook. So you see.
All right, here's Talia, sir.
Talia, they calling for you. Talia, they want you to cook.
Okay.
Turn on the camera and cook.
So let Talia cook. So Talia, you think you can manage these questions?
Yes, sir.
All right, so the people are calling for Talia, let Talia cook. Let her cook now. All right, go ahead, Talia. You can read the question and answer. All right.
Sir, I don't feel like reading. So,
All right, let me read it. Three matrices, sorry, Q, R, and S are as follows. We have Q, this is the matrix Q, and we have R, this is the matrix R, we have S, this is the matrix S. And they want us to explain why the product QS is not possible.
okay, so first you have to find out what kind of matrix it is, right?
Mhm.
So Q is a 2 by 2 matrix. R is also a 2 by 2 matrix.
Is
And
that R? Oh, sorry, yeah, sorry.
S is a 3 by 2 matrix. So it's set to explain why the product QS is not possible. So since Q is a 2 by 2 matrix and S is a 3 by 2 matrix, and based on the order of the two, they are not compatible. Is that simple?
And why aren't they compatible?
They aren't compatible because the number of rows and columns aren't the same.
Hmm. Tighten it up a little. Come on,
So
cook.
the number of columns in the first one supposed to be the same as the number. No, wait.
You're correct, you're going correct.
The number of columns in the first one is supposed to be the same as the number of rows in the second one.
Good. So they are not the same, so they are not compatible. Right? Excellent. Excellent. All right, so the people wanted Tally to cook, and she did cook. All right, very good. She did cook. All right, so who else didn't cook? Well, Akeem, I'm putting this one, but no, I won't do that. So SR. So the next thing they want us to state the order of SR. So who want to finish off this one? Anybody?
Sir,
Me, sir.
All right, go ahead. Go ahead.
So the order of the matrix S is a 3 by 2. And the order of matrix R is a 2 by 2. So the multiplication is compatible because the number of columns of S is equal to the number of rows of R. And to find the matrix product, we just have to write back the number of rows in S with the number of columns in R. So that would be a 3 by 2 matrix.
Right. So basically, excellent, very good. So basically taking the n numbers, and the n numbers will give you the product. And the inner numbers will determine whether they are compatible. So if you want to determine, just put down the two numbers, and if these two are the same, they are compatible. And I like just now when we had QS, Q is a 2 by 2, S is a 3 by 2. You see the two inner numbers are not the same, so they are not compatible. As easy as that. All right. So the answer is a 3 by 2. So I see a lot of persons learn that. All right, a lot of persons learn that. So the outer number will determine the product. All right. Let me do this last one, since this one is a nice one. So given that M, the matrix M is equal to 2x, 2, 9, 3, calculate the values of x when the determinant is equal to 0. Last question, and we'll call it a night. All right. Then I'll give you all some tips, and then we'll call it night. After this question, I'll give you all a few tips. So to find the determinant, the formula to find determinant, it's AD minus BC. And they told us that the determinant is equal to 0. So all we do is equate this to 0. So in order to find the value of x, we just set up the determinant. So we know A, this is B, this is C, this is D. So we know A would be said to be 2x multiplied by D, which is 3. Subtract B, which is 2, multiplied by C, which is 9. And this is equal to 0. Because that's what it told us, right? So 2x times 3 would be 6x. Subtract 2 times 9 is 18, is equal to 0. So 6x would be equal to this 18 is subtracting, you take it over, add 18. Well, 0 plus 18 would be 18. And x would be equal to the 6 is multiplying, we take it over to divide. So we'll have 18 divided by 6. X is equal to 18 divided by 6 is 3. So x is equal to 3. So that is our value for x. As easy as that. All right. So let me not scroll, because if I scroll, I'll see another nice question, and I'll say, let's do that last one. So we'll stop here. So before I stop, before we close up and end the live stream, let me just give you some tips on how you can prepare for the exam. The exam is for the, how much you said, for the 9, for the 1?
For the 1 days
For the
away.
one.
For the 1. Whew. I'm scared. Oh my gosh. Anyways, just joking. So The exam is far, the 1 more day is away. Now here's the beauty about maths. As I said earlier, the paper is worth 100 marks. You don't need to get all 100 to pass the exam. You don't need to get 100 or 200 to pass the exam. There are enough questions on the paper. As long as you use some your God-given common sense, you will score above 50. All right. You also have a very powerful tool, which is a calculator. As long as you know to use a calculator, that will give you some additional marks as well. So with the combination of the marks that you will get when you use your calculator and also you use common sense, there's no way you can fail the exam, but we cannot panic. You cannot panic and think this exam is hard because we did a few hard questions tonight that you didn't understand. You don't need to get everything right. You just need to get number one is fractions, cover fractions and probably a consumer arithmetic. You'll score some marks there. Number two is little factorization and little algebra, solve something. And number eight, you probably got get a pattern, you draw some pattern, complete some table, and there are some other easy questions. Number seven, little functions, you know. So there are some questions and there will be some questions in the paper that you can score some marks. So don't approach the exam thinking that you need all 100 to pass. You just need to do your best, use your calculator effectively, read the questions carefully, understand the terms, know what you have to do when you have to solve, factorize, understand what the question is saying, put yourself in the position of the question, especially when dealing with consumer arithmetic, put yourself in the position and answer the question. And then you do your best. Try to score above the minimum you should get is above 40. Try to score above 40. And this is just a pass, right? I'm not talking to people that want to do excellent. This is just people that fighting mathematics. You think you will fail. This is how you will pass. And then there's the paper one. There's a document that all the schools should have with us several quizzes. You want to practice the 60 questions, you practice those things repeatedly over and over, and you'll be good to paper one. But you can't just not prepare for the paper one and think, oh, the questions will come back, so you'll get them. You need to practice. I'd say you need to practice the paper one. Ask the teachers for the document with the quizzes and you practice them move on. And then you got your SBA, and that's how you pass. But yeah. So I'll put my students on the floor on the spot and ask if they want to get from a student's perspective, what advice do you have to give, and then we'll close off. Anybody who would like to give any advice? So if you want to see Talio face reveal, you can also comment face reveal from Talio. And if you want us to go again, if you want us to do another live, you can also tell us um, in the chat if you want us to do another live, and we'll decide. So anybody would like to share any words of encouragement from your perspective as a student? Floor is yours.
There.
Go ahead.
I think if we do the other life, we should do less questions so we could cover more topics, because we only cover three topics, right? Yeah.
But here's the thing. The reason why the thing is we cover those topics. Here's the word. I'm trying to find the word.
In depth.
Yeah, in depth. All right. We didn't just touch the surface. We did one question. We did a variety of questions. That means, we have a variety of ways to approach different kind of questions that will come under the topic, rather than just scratching the surface and doing one. Right? That is why. So when we come again, we look at the topics that we didn't do. If we come again, that is. Yes, Amber.
Sir, I've gotten a personal request for us to do transformation.
Okay. All right, we'll see. So yeah, the persons on the live, I want us to come again. My students, y'all enjoy the live?
Yes, sir. It was a good experience.
Yes, sir.
Yeah. I just hear from Amber. Yes,
I was
Talio.
enjoying myself in the chat.
When I pull up a picture with Talia for show them.
Anyways, no. All right, so Anybody would like to give any advice before we close off? I'll give one person the floor.
Sir, why you will enjoy?
Advice, and then we'll talk about that, Troy. Anybody? This class here, a lot of debaters here, impromptu.
Sir,
Hmm?
for advice, I think I would tell everybody who's watching this live right now, stop using AI. No, on a serious note, don't use ChatGPT. Please just actually do it, memorize the steps, and you're good. Also work past papers. Past papers help. And practice not using your calculator for paper one. Okay, good. That's it.
Amber is very blunt. Love to hear.
ChatGPT to save you sometimes though.
But not
I
all the
mean,
time.
yes, that's a point. Sometimes.
But you can't do it all the time.
Yeah,
Sometimes
yeah.
if you're struggling, what if you say that soon as you boss a question, oh, I don't know how to work this thing. Let me take a picture and send it to ChatGPT. You're not using your brain. Because you're training your mind to do like that, right? You're training your mind to depend on the AI and the ChatGPT. When you go in the exam, you book up with a question that you don't know. You think, oh my, if I had ChatGPT now. But you want to train yourself, going through the rigors of not understanding the question, getting it wrong, and going. Anyway, so we'll stop here for tonight, because my students are all leave after live, and we'll take. So we'll stop here for tonight. I trust that everybody enjoyed. You learned something new. If you learned something new, tell us in the chat, so we'll feel motivated to come back. And I'll see y'all next time if 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 if
Sir,
the yeah.
why you trying to say your master's in ChatGPT?
Anyways, we'll stop here. So they are take care, keep practicing. If you didn't answer anything in the video, go back and look back and